Hello everyone. This session I want to share with you an incredible concept that has the power to enhance your curiosity. No, it is better to say ignite your curiosity, enhance your problem solving skills, and open doors to endless possibilities. I'm talking about the fundamental principle of counting. It is not just another mathematical concept. It is a key that unlocks a world of discovery and growth. By understanding and applying it, you can solve complex problems, think critically, and approach challenges with confidence. It improves your logical reasoning skills and encourages you to find creative solutions. It's true because many problems, not only from the field of mathematics, from physics, chemistry, you'll be surprised to know by using the concept of APC, that is fundamental principle of counting, you are able to solve. By knowing the fundamental principle of counting, you are automatically getting prepared for many future opportunities. Why? Suppose you are interested in pursuing a career in science. It may be technology, engineering, mathematics also. I am talking about applied mathematics also. This APC or fundamental principle of counting establish a solid foundation for understanding concepts, many concepts in mathematics, for example, probability theory and statistics. These are integral to many advancements of mathematics. And you'll be surprised to know that counting principles offer an exciting gateway to the world of puzzles and games that you like most. It will engage your mind, challenge your intellect, and ignite your passion for mathematics. Through permutations, combinations, together they are known as combinatorics and other techniques, you will start a journey of exploration and growth where every problem becomes an opportunity to learn and excel. So, my dear, all of you, master this concept of fundamental principle of counting with greater enthusiasm and thirst for knowledge. Let it inspire you to push to become a problem solver of the century. Enjoy the joy of counting and discovery and watch as your understanding of the world expands and your potential goes up. May this journey of counting and discovery be filled with inspiration and success. Let's start with the easiest problem for this session, where you have to go out to meet your friends and you have four different shirts available. How many ways you can select one of the shirt? You will ask, why so easy question for us? We know how to answer. This one I will select, or this one, or this one, or this one. So my selection can be done in four ways. It's true. This is really a very simple problem where by selecting one of these you can go out, so it can be done in four different ways. Now problem will be a bit difficult where if I ask you, you have three trousers and two shirts available. How many different ways you can go out? You will say that this I know, I do it every day. I write trousers this manner, T1, T2, T3. I have three trousers here. I have two shirts here, S1 and S2. So combination I will be doing this manner, trouser 1 with shirt 1. number 1, trouser 1 with second one, trouser 2 with first one, trouser 2 with second one, trouser 3 with first one, trouser 3 with second. A very smart friend of you told that I knew the answer. Why are you counting this manner? You ask me, I can answer. Here I am selecting 3 ways, here I am selecting 2 ways. He will say that the answer is 3 into 2. Really you got 6 combinations only. 6 different combinations of trousers and shirts possible over there. So this way writing may be difficult when number of outfits going to be large. There are 10 trousers and 15 shirts available. So how many different ways you can go out? You cannot do it by this kind of consideration. You have to use some mathematical technique that we are going to discuss in fundamental principle of counting. Let us see next one, where you have flipped a coin once. What are the outcomes when a coin is flipped once? Outcomes are like this. In the first flip, the outcomes are written in the form of set. It is going to be S1 equal to H2, H and head and tail. If you flip the coin twice, then in the first tossing there may be a head, second tossing there may be a tail. But this situation is a probabilistic one. Which one comes you don't know. You need to write all these things. There may be tail in both the trials. There may be tail here, head here. There may be both the heads. So this time, some of you are habituated writing in the form of set. You will say that the sample space consists of 4 points like this. If I ask you a question with flipping of 2 coins together, this is the answer. So flipping of 1 coin twice or 2 coin once, the outcome will be the same. Problem will become difficult if you are supposed to find number of ways by listing the elements of this set by counting only. Like 4 coins are tossed together. What are the outcomes? If you have the past experience, you will say that it is 16. I have done all these by writing in the form of set. But this time, today's class, we will be discussing how to get all those things quickly. So let us go for another problem where again I have tried to solve it by using just recording the result of the experiment one by one and then counting how many cases are there. But this will take long time if you practice at home. Where how many numbers of 2 digits can be formed out of the digits 1, 2, 3, 4, no digit being repeated. So I have taken digits this manner first. Start with the first digit 1, 2, 3 or 4. As you are going to form 2-digit number, there is units place, there is tens place. Okay. So if you start with 1, this place can be filled with 2 or 3 or 4. So it is 1, 2, 1, 3, 1, 4, which I have listed here. 1, 2, 1, 3, 1, 4. If you start with 2, this is one possibility when you are starting with 1. If you start with 2, it will be 2, 1, 2, 2, 2, 3. No, 2, 2 will not be there. Repetition is not allowed. So it will be 2, 3 and 2, 4. This way you can start with 3, 3, 1, 3, 2, 3, 3. You can start with 4 also. Just write it is 4-1, 4-2, 4-3. But somebody says that answer is very easy to know, that if I multiply that out of 4, I am taking 4 into 3 ways, then it is coming. Then you will ask me, how is it possible? This is actually fundamental principle of counting, where the digit at the tens place can be taken in 4 ways, digit at the unit place can be taken in 3 ways. So it is 4 into 3. This is actually multiplication rule of fundamental principle of counting. I am going to discuss again. I put forward another problem for you, where there are 2 dice, they are colored. One is white and the other one is red. The question is, how many outcomes are there? If you have done probability in class 9-10 level, you must have done this, that number of cases will be 36. That white die taken this manner, 1, 2, 3, 4, 5, 6, red die taken this manner. It is better to say that die is not white, it is black, because I have taken black numbers over there. So here number of cases, if you start with this 1, 1, 2, 1, 3, 1 this way, 6, 1 this way, listing is not possible. But if we use fundamental principle of counting, then the first die will show outcome in how many ways? 6 ways, because it can show 1 or 2 or 3 or 4 or 5 or 6. Second one also 6 ways, so it will be 36 ways. This is fundamental principle of counting. This is multiplication rule of counting. What is that principle? According to this principle, if one event can occur in m different ways and a second event can occur in n different ways, then total number of ways in which both the events can occur is m into n. Okay? It's very easy. Suppose you are going from place A to place B in 3 different manners, and you are coming back to the point A. How many ways you can travel between these 2 points, A to B, then B to A? So you can go from A to B in how many ways? 3 ways. You can come back how many ways? 3 ways. This is 9 ways. If I refer this one as root 1, root 2, root 3, then going from A to B going to be like this: R11 going by root 1, coming back by 1, R12 going by root 1, coming back by 2, R13 going by root 1 from A to B and then coming back by root 2 or root 3, like this. So it can be done in 3 ways. Okay. Now you can go from A to B by following this route here. That suppose you are following A to B, you are going from A to B starting with 2, root 2. Then you can come back with 1, come back with 2, or you can come back with 3. Similarly, if you are going from A to B by root 3, come back by 1 or 2 or by 3. Can be done either this way or this way or this way. So how many cases are there? 3, 3, 3. It will be 3 into 3 into 3, 9 ways. So fundamental principle of counting extended for 3 different processes. One process going from root 1 or root 2 or root 3. Then coming back also by root 1 or root 2 or root 3. Not 3 processes, 2 processes. Just going from A to B, no? It may be, it is just going and coming back. Going can be done in 3 ways, coming back can be done in 3 ways. This way you think. 2 processes are there. Going from A to B, then coming back from B to A. So going 3 ways, coming back 3 ways, it will be 9 ways. But if we want, then you can extend the concept for 3 different processes also. One process can be done in M ways, another process in N ways, third one in P ways. All 3 together can be done in M into N into P ways. Just to give you one example for you. Suppose in the previous sum, like A to B, you are going by following these 3 routes. Then from B to C, you can go by following 2 different routes. How many ways you can go from A to C via this point, via this place B, and then come back to the point A. So here actually the first process going from A to B, second process going from B to C, third process going from C to B, then from B to A. So here fundamental principle we are using for 4 different processes. Say L, M, N, P. First process can be done in L ways, second one M ways, third one N, fourth one P. So all together these can be done in L into M into N into P. 4 ways. I mean, so many ways. So in our problem, how many ways you can go from A to B, then B to C, then C to B, then B to A. It means you can travel between A and C by following the point B. Your answer going to be first process how many ways? 3. Second one 2. Then C to B how many ways? 2 ways. Then B to A, this is also 3 ways. So 36 ways you can travel. And if you do the experiment writing all the processes the way I did here, then really you will find. You note this one as route 1, 2, 3. This is 4, 5. So one of the route I am telling you, it is R1, 4, 4, 1. Going by 1, then by 4, then coming back by 4, coming back by 1. This is one way. This will count all 36 cases will be there. But today's class, we are not going to discuss like this, writing all the elements, all the processes, listing here and then telling the answer. We will be using fundamental principle of counting for 2 processes, for 3 processes, or for more number of processes. Okay? So let us start with one very interesting problem. This girl among 8 children of a locality. Okay? 8 children are there. They travel a park in the afternoon every day. Sometimes they sit over there. How many ways these 8 children can occupy this bench? This bench you all can see how many ways they can occupy. This is the question. And the second question, how many arrangements are possible if the youngest one sits at the left hand end to the bench? This is very interesting question because I am going to use fundamental principle of counting, not only L, M, N, P. 8 cases will be there. Why? Here number of cases for 8 children, 8 seats are there. We are writing this manner. This is 1 seat, second one, third one, fourth, fifth, sixth, seventh, eighth. The first part we are answering. So out of 8, the first place, there is no restriction here, you can see. It can be filled in 8 ways. This one can be filled in 7 ways. This one 6 ways, 5 ways, 4 ways, 3 ways, 2 ways and 1 way. What I did there? I am using fundamental principle of counting for 8 cases. First place can be filled in 8 ways. When one child is at this place, automatically he cannot go for the second place. He has occupied his or her place here. So this place available for 7. It can be done in 7 ways. This place can be done in 6 ways. This one 5, this one 4, like this. So number of ways by FPC going to be 8, 7, 6, 5, 4, 3, 2, 1. By counting, by multiplying, you can get. Now the problem with this child, in another imaginary arrangement, suppose she started trying to occupy the left hand end of the bench, this side. She want to occupy this side only. I mean this portion. This is 8. This will be occupied by this girl. How many ways it can be done? Then arrangement. Here, if we use this condition that she will be occupying at this place only, then she has no choice for the other places. Okay. So other 8 seats, this is occupied. So no arrangement for this. No selection from remaining 7. So this is occupied by her. Even this is not a way. This is just a condition given in the problem. She will be occupying this. So how many remaining places are there? 7. Apply FPC, that fundamental principle of counting, for these 7 places. Here counting will be done this manner. This place in 7 ways, into 6 ways, into 5, into 4, into 3, into 2, into 1. You understand? So this way you can find total number of ways they can sit over there. Next one. See, that principle of counting, the multiplication rule is not required always. Addition rule can help us. Like the first sum, I have started with you that selection of shirts out of 4. You said either this or this or this or this. This way 1 plus 1 plus 1 plus 1. 4 ways you can split that manner. That is very simple. You are entering a hall where one side of the hall has 2 entrances and the other side 3 entrances. How many ways you can enter the hall? You will say that I will go by side 1. How many choices are there? 2 choices. This can be done in 2 ways. And then you say that no, I will go by this side. Then how many ways this side you can enter the hall? It can be done in 3 ways. So how many different ways you can enter the hall? One process, that selecting side 1 to enter, can be done in 2 ways. Then selecting side 2 to enter can be done in 3 ways. So this is going to be 5 number of ways to enter the hall. So this is another fundamental principle of counting, where if an operation can be performed in m different ways, another one n different ways, 2 operations are mutually exclusive. I mean, one of them will occur, not both together. I mean, you are in side 1 or in side 2. You can't be in 2 sides together. So how many ways you can enter the hall? These 2 options and these 3 options you can enter there in 2 plus 3, 5 ways. You understand? Suppose there are very good books. When you went to buy book from a bookstall, you see that there are 10 very good physics books and 9 different very good maths books. How many ways you can select one of the books? Because you don't have money to buy all 19 books. You have money to buy one only. You have seen that all 10 books are good in physics and 9 books are good in mathematics. So your selection will be, you like both the subjects. So selection will be either one of the physics book or one of the maths book. So in that case, if there are 10 physics books and 9 maths books, your selection will be 10 plus 9. 19 ways you can select. This is fundamental principle of addition. Now problems gradually will become difficult. You understood the fundamental principle of addition, fundamental principle of multiplication. In most of the sums, you will apply both the principles together. See this problem here. Naveen, one of your friend, goes to a movie. Cinema hall has 5 entrances and 6 exits. In how many ways can Naveen enter and exit from the hall? It's very easy to think, because first case, when going into the hall, how many ways are there? 5 entrances. So 5 ways. So first process can be done in M ways, that is 5. Second process, when you are coming out, it can be done in how many ways? 6 ways, because 6 exits are there. People are hurrying to leave the hall when the show gets over. They will hurry to reach their home. So how many ways you can enter and come out? Friend Naveen this time, not you. Parents allow, then you go, no. This will be 30. If parents allow, you will definitely go, but your number of ways to enter the hall and coming out of it will be 30 different ways. You all understand? 15 buses running between Delhi and Mumbai. Okay? In how many ways can a man go to Mumbai and return by different bus? Going this way, coming back this way. In how many ways it can be done? This can be done in 15 ways to go and 14 ways to come back. 150 and 60, that is 210. Alright? Because one process to go from Delhi to Mumbai can be done in 15 ways. Then coming back from Mumbai to Delhi in 14 ways. So it is 210 ways. You can go from Delhi to Mumbai, then Mumbai to Delhi. This is a problem in your school. 36 teachers are there. Authority has decided. Actually, it is not your problem. If authority asks, then it will be your problem. 36 teachers are there. One principal, one vice principal are to be appointed out of 36. In how many ways can this be done? Again, by fundamental principle of counting, that is multiplication rule. That is, out of 36, all of them are competent. That's why they have taken the name of all 36 teachers. One of them is to be selected for principal and one for vice principal. Out of 36, if all are competent for the post of principal, how many you can select one principal out of 36? Can be done in 36 ways. Either teacher 1, teacher 2, teacher 3, this way. All 36, one of them. And then for vice principal, how many are remaining? 36 and then 35. Because same teacher cannot go for principals and vice principals post. Multiply these two together. This many ways you can find. Let us solve one coding problem here. Not actual coding, the way you do by CSS, JavaScript and HTML. Here just mathematical coding. For example, CA23 is a code and it consists of 2 distinct English alphabet followed by 2 distinct numbers between 1 and 9. For example, they have given a code CA23. C has come from the alphabet, A also, English alphabet, 26 letters are there and a digit. Two distinct numbers between 1 to 9. 1 to 9, how many are there? 9 numbers. So how many ways you can make a code where first 2 are made from letters of English alphabet and third and fourth taken from the 9 digits. So obviously this can be taken how many ways? 26 ways. This one 25 ways, because one digit without repetition you are doing no distinct. They said distinct. So this can be selected in 26 ways. This place can be selected in 25 ways. And how many digits are available? You can see 1 to 9. So this can be filled in 9 ways. No repetition allowed. This place can be filled in 8 ways. So 26 into 25 into 9 into 8 required number of ways. Alright. Let us solve next one. How many 5-digit telephone numbers can be constructed using digits 0 to 9 if each number starts with 67? For example, this one. 67125. Okay. How many 5-digit telephone numbers will be there? They are starting with 67. So 5-digit means units place, tens place, 100, 1000 and 10,000. Places are there. These 5 places you have to fill up. This place can be filled up how many ways? With 6 and 7. You cannot change it. But this you can. Okay. And no digit appear more than once, they said. You cannot repeat. So if you have kept 6 and 7 fixed over there, 0 to 9, how many digits are there? Number of digits is equal to 10. So this place can be filled in 10 ways. This one in 9 ways. This one in 8 ways. Okay? Why? Because repetition is not allowed. If this place filled with 10 numbers, 10 digits, one of the 10 digits, then it can be done in 10 ways. This one 9, this one 8. So 720 ways. This is a very interesting question. For a set of 5 true or false questions, no student has written all the correct answers. No students have given the same sequence of answer. Then what is the maximum number of students in the class for this to be possible? After giving these 3-4 conditions, you can find number of students easily. Why? Because they said that you are answering 5 questions. Suppose you have answered this manner. True, true, false, like this. Yours complete. One of them answering false, 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 true, false. These sequences will not repeat. Your way of answer will say that you are a person present over there. You have answered the paper. And this sequence will tell the presence of another candidate there. All these sequences will be different. They have observed, after conducting the test, they have observed that all these sequences are different. Then, how many students, how many maximum number of students are there? Minimum maybe 1, 2, 3, 4, whatever. But maximum how many? This is very interesting. Because when 5 true or false questions are there, how many sequences possible? You first count. How many sequences will be there? That I am writing. Sequences are being arranged in these 5 boxes. We find number of sequences possible. This one can be filled in how many ways? 2 ways. 2 ways. This one can be filled in how many ways? True or false? 2 ways. This one in 2 ways. This one in 2 ways. This one in 2 ways. So all the candidates present over there have answered in how many ways? That is 2 into 2 into 2 into 2 into 2. That is 32 ways. So 32 different sequences are there. This true, false like this. So number of students will be how many? No 2 students have given the same sequence of answers. Maximum number of students in the class. No student has written all the correct answer. This is another condition. If you forget, then it will be wrong. So if you say that my answer is 32, then you are wrong. Why? Because no student were able to write all the correct options. See, it is given, no student has written all the correct answers. Correct answer, all the correct answer out of these 32 sequences, all the correct answers will be one sequence only. Only one sequence is correct. That sequence may be like this. False in the first case, false in the second case, true here, false here. This is the correct. This is the only sequence which is correct. So, this you have to exclude. 32 candidates are there. But as no student has written all the correct answers, out of these 32 sequences, one was correct. So we must subtract that. It will be 32 minus 1. Alright. Now let us go for next one. How many outcomes are there when a coin is tossed and a dice is rolled? Coin tossed. Coin means head or tail, and dice is rolled. Its outcomes are 1, 2, 3, 4, 5, 6. Don't draw the tree diagram, because you have to get the coin and a face of the coin. The face of the dice. You have to get one face of the coin and one face of the dice. This is the problem. So getting one face from the coin can be done in how many ways? 2 ways. Getting one face out of the 6 faces of a dice, it can be done in 6 ways. So total number of outcomes will be 2 into 6, that is 12. 12 you could count easily. H1, H2, in probability we will do this manner, H4, H5, H6. It may be started with tail also. Maybe, then how many options are there? It may be tail 1, tail 2, 3, 4, 5, 6. Okay. So in total 12 cases are there. But by now you get it by counting, not by drawing diagram or by writing all the possibilities in the form of set. In a cafeteria there are 4 types of desserts: cake, ice cream, pea and pudding. Then 3 types of drinks: water, juice and soda. How many different combinations of dessert and drink can a person select? Then this is very easy. How many different combination of dessert and drink? You have to take either dessert or drink. If you tell me, then I will take one of them. I will not take together. Okay. So for me, selection will be either or. For you, it will be this and this. You like desserts, you like drinks also. But restriction is you can take only one dessert and one drink. So out of 4 you can select one. It can be done in 4 ways. Out of 3 drinks can be done in 3 ways. It is 12 ways. Okay. This is a very simple problem. This is a very interesting question. A mint prepares metallic calendar specifying month, dates, days in the form of monthly sheets. 1 plate for each month. How many types of February calendar? What is the meaning of February calendar? February calendar means they are telling you to focus on February month only. How many calendars you will keep ready for the future use? Suppose in future you have got a job in a mint. Mint authority has told you, you keep calendars ready for future use. What is this? Surprising. How can I keep all the calendars ready? If you work for next 40 years, then after that another one will come. He or she will work for 40 years. How can I keep calendars ready now? But you know fundamental principle. You will say that it's very easy. When I am forming a calendar, this a particular year can be a leap year. I am writing LY or NLY, non-leap year. See, either it may be leap year or non-leap year. Just one of the option, 2015 is a non-leap year. It cannot be both together. So for a particular year, we have two options, either leap year or non-leap year. Now starting day of the week, it may be Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, whatever. Okay, all 7 days are there, but all 7 days cannot be starting day for a particular year. One of these only, not all. So total number of calendars you will keep ready, the number of ways you can select the first day of the year, and by deciding whether it is leap year or non-leap year. So again by fundamental principle, that month, that year may be leap year or non-leap year, it can be done in two ways. It can be one of the days given here, so it can be done in 7 ways. So recurrent number of ways going to be equal to 14. So total number of metallic calendars, different types of metallic calendars you need to keep ready, equal to 14. 14 calendar will solve the purpose of any year coming in the future, or solve the purpose of the past years. Let us see next one. How many ways can this diagram be colored? Subjected to the following two conditions. Each of the smaller triangle is to be painted with one of the three colors. There is red, there is blue, and there is green. How many ways you can color? So that two adjacent triangles are not of the same color. It means you cannot take red, like this you cannot take. Or you cannot take, say this is blue and this is blue. No, this is not adjacent, this one. Or this one. You cannot take this one. Okay? Two adjacent triangles will not have the same color. How to start coloring? Very simple. You can start with one of them. So what I am going to do, I will be coloring this triangle first. It can be done in how many ways? Either red or blue or green. 3 ways. For that, this one can be filled in how many ways? 3 means I have taken red. Then my option is B or G. 2 ways. Now with this central one, how many ways this can be filled in? One particular color is taken here permanently. Then I am thinking about remaining 3. It can be done in 2 ways. This one can be done in 2 ways. This one also 2 ways. So how many ways it can be done? Can be done in 2 into 2 into 2. That is, no. These 3 also. Here also there is choice. So there will be 3 into 8. That is 24 ways. 24 ways this triangle can be colored. I told you one method. It will be your effort to start with any one of the triangle here. Then check whether answer is varying or not. You must write in your comment box that whether I have got a wrong answer here or not. Okay? Let us see this one. How many number of different signals that can be made by arranging at least 3 flags in order on a vertical pole if 6 different flags are available? How many ways it can be done? This problem going to be bit complicated for you, where there are, find the number of different signals that can be made by arranging at least 3 flags in order on a vertical pole if 6 different flags are available. 6 different flags are there. They are of different colors. So how many signals can be made by arranging at least 3? Out of these 6, you have to take at least 3 flags for signaling. So let us start the problem this manner. We are taking 3 flags. Minimum number we are taking first. Okay? 3 flags. How many ways signals can be made? 3 flags means 3 different places. How many flags are there? 6 different flags. So this place can be filled in how many ways? 6 ways. This one can be filled in how many ways? 5 ways. This one 4 ways. I think you all understand. 6 flags. I am using 3 only to form a signal. But how many ways, how many different signals will be formed? Because this first flag can be selected out of 6 in 6 ways. This one 5, this one 4. So this is going to be 5 into 4 into 3. This is 60. I can use 4 flags for signaling. So how many ways this can be done? Here can be done in 6 ways. This one 5, this one 4. So this is going to be 6, 5, 4, 3. 30 into 12, 360 ways. I can use 5 only. 3, 4, 5. How many ways it can be done? 6, 5, 4, 3, 2, 1. No, 3, 2. So it can be done in multiply, it is going to be 720 ways. And then how many ways? 6 flags can be used for making signals. Here it will be 6 into 5. This can be done in 4 ways. And why we have multiplied? Why did not take 6 into 6 into 6? Because repetition is not allowed. Same flag you cannot take at 2 places. That's why repetition is not allowed. You have to understand. So this is also 720. So total number of signals can be formed going to be 60 plus 60 plus 720 plus 720. This is nothing but this is 0. This is 4, 6, 6, 1, 5, 6, 0. I am getting like this. No, not like this, because 360 I forgot to add, 360 to be added. So 1440, 1440 plus 360 plus 60, 420. That is 1440 plus 420. So this is 0, 6, 8, 1860. I can see here. But I think I have done one mistake here. Here multiplication was wrong. Because the sum I did earlier, here it will be 6 into 5 into 3. That's why. This is 6 into 5 into 4, not 3. So this will be 120 ways. So this is 480 and 1440. So 1440 plus 480. 1920 ways are there. I mean 1920 different signals can be formed. This is not a difficult one. Each of the 6 squares in the strip shown is to be colored with any one of 10 different colors. So there are no two adjacent colors. 10 different colors are there. Adjacent colors will not be same. So how many ways this place can be filled in? 10 colors, this can be filled in 10 ways. Same color you cannot take here, it will be done in 9 ways. This one 9 ways, because the color you have used at the first place you can use here. This is not signaling, it is just you have 10 different colors, you can use any number of times. But the condition is two adjacent boxes will not have the same color. So this one can be filled in 9 ways, 9 ways, 9 ways. So answer going to be 10 into, this is not a difficult one, you have done yourself. Then this one is a very interesting question. Find total number of ways in which n distinct object can be put into two different boxes so that no box remain empty. How many ways this can be done? N distinct object can be put into two different boxes. Not so many boxes. Only 2 boxes are there. How many ways you can put objects into boxes so that no box will remain empty? How many objects are there? N objects. For n objects, we name them as A1, A2, A3, An. N objects are there. This is box 1, we are labeling the box. Box 1, box 2. So for one particular object, which box you are going to select? It depends. You can take any one of these. So A1 can be placed in these boxes in 2 ways. A2, 2 ways. A3, 2 ways. You can go to box 1 or box 2. And last one also 2 ways. So how many times, how many ways total? It will be 2 into 2 into 2 into 2 n times. So this is 2 to the power n. Out of these 2 to the power n ways, you have to see one condition. They said that no box remain empty. So there may be situation like this. You have to exclude this situation when there is 0 object and n object here, or n object in the first box, 0 object in the second box. These 2 cases are not allowed according to the condition of the problem. So 2 to the power n number of ways you have placed, it's fine, but these 2 cases are removed. So number of ways you can place the balls into the boxes so that no box will remain empty will be 2 to the power n minus 2. Okay. Now let us go for next type of problem, that how many different numbers are there between 100 and 10,000 in which all digits are distinct. They are between 100 and 10,000. So numbers may be of 3-digit numbers. For 3-digit numbers, what you do? Units, tens, 100. All digits are distinct. You cannot take 0 at the 100 place to get a 3-digit number. So this place can be filled in 9 ways. How many ways? Tens place can be filled in 10 ways. This one 9 ways, this one 10 ways. Because you cannot take 0 here, but 0 can go there. This place can be filled in how many ways? No. All digits are distinct. So if this place occupied by any one of the non-zero digits, Then digits are from 0 to 9. 10 digits are there. 1 digit is in use here. So this place can be filled in 9 ways. This place can be filled in 8 ways. So it will be 81 into 8 ways. That is 648 ways. Okay. So number of 3-digit numbers you got. 10,000 is the first 5-digit number. So next possibility are with 4-digit numbers. 4-digit numbers will be there how many? 4-digit numbers may be like this: units, tens, 100, 1000. So again this place cannot be filled with 0. Then it will not be a 4-digit number. 0 to 9, 10 digits. We can take this one 9 ways. This one 9 ways. 0 can go there, but 2 are in use. So this one 8 ways. This one 7 ways. You multiply, then add with this case and total whatever you are getting. Okay, that will be required number of numbers between 100 and 10,000 in which all digits are distinct. Alright. And then next one, how many odd numbers less than 10,000 can be formed from the digits 0, 2, 3, 5? Repetitions allowed. That may be how many odd numbers less than 10,000. 1-digit number is also possible. Numbers of 1-digit number, how many? It may be 2 or 3 or 5. It will be 3. Number of cases will be 3. Number of 2-digit number will be how many? Units and tens. 0 cannot come here. So this place can be filled in how many ways? Any one of these 3. It can be done in 3 ways. Here 0 can be there. But they said that these are odd numbers. I did not see in the first case 2 is an even number. So it is actually going to be 2 is the single digit number which is even. So 3 minus 1, 2 cases will be there. In this case, when you are going to form numbers less than 10,000, it is very easy. But number odd and less than 10,000 you have to consider. If it is less than 10,000 and odd and 2-digit number, then this place can be filled in 3 ways. This place how many ways? This place you have to make odd. So you cannot take 0 here. It can be taken, for this place can be taken 3 or 5 only. 3 into 2. Only 6 2-digit numbers will be there. And then number of 3-digit numbers, how many? Units, tens and 100. How many will be there? This place can be filled in. No, you consider this place first. This place can be filled in any one of the 3 ways. That 3. This one 0 can be there. So it can be filled in 4 ways. This place it will be odd. So it can be filled in 2 ways. So this is 24. Total going to be 32. These 32 odd numbers are there less than 10,000 and they are formed with these 4 digits only. Today's session I am going to ask you one question like this, which we are going to solve in permutations and combinations. Next session will be on permutations and combinations. How many paths? And starts from here and goes there. It's a 4 cross 6 ordered grid and can move along this grid either in forward direction or leftward or rightward, but never backward. How many ways it can travel from this end to this end? You understand the problem? It can go towards right, towards left, or towards right, I mean forward, or leftward, or again forward direction. How many different ways it can go from this end to that end? This you have to find. Okay? Thank you. See you again.